All right, there's another topic that we need to cover, and that is the topic of z-scores. Okay, z-scores are just it's not a complicated idea. It's just the number of standard deviations we are from the mean. Deviations a point is from the mean. Okay, so let's say we are looking at the numbers 10, 12, 12, 14, and 17. These are the ages of kids in science club, and n is equal to 5. Our mean, x bar, was we added up all of these numbers, and we got 65 divided by 5, which gave us a mean of 13. This is our mean. Okay, so a z-score is just how many standard deviations we are from the mean. From before, we calculated the standard deviation, and we got the standard deviation to be equal to the square root of 7, which was 2.626, I believe. Let me just verify. I'm sorry, 646, 2.646. That is our standard deviation. Okay, so our mean is 13 and our standard deviation is 2.646. So if we take one of the students, 12, a student is 12 years old. What is the z-score? We ask how many standard deviations from the mean are we? Okay, well, 12 is 1 year from the mean, and each standard deviation is 2.646 years. Okay, so the z-score that we're going to get is basically 12 minus 13, which tells me that we are 1 year below the mean, but then we're going to divide this by how big each standard deviation is. So the kid who is 12 years old, he is 1 divided by 2.646. He is 0.378 standard deviations from the mean, okay? 12-year-old student, oh, and it's a negative, is negative 0.378 standard deviations from the mean. Or in other words, he is 0.378 standard deviations below the mean. All right, so what about the student who's 17? What is his z-score? Okay, the 17-year-old has a z-score of, well, 17 is 4 years away from the mean. 17 minus 13 gives us, or 4 years above the mean, and each standard deviation is 2.646. So we do 2 divided by 646. I'm sorry, 4 divided by 6. 4 divided by 2.646, and we are 1.512 standard deviations from the mean. Okay, so the overall way to remember all of this is that a z-score is the number of standard deviations we are from the mean. And we can compare different z-scores and make comparisons. Sometimes you like formulas. All we have to do is we take the value that we're looking at, subtract off the mean, which is x bar, and divide by the size of each standard deviation. Okay, this is a formula for z-score, but just remember, this is the number of standard deviations from the mean. If you like steps, just basically take the data point and subtract the mean. Then divide by the standard deviation. That will give you the z-score. Okay? We can compare z-scores. Okay? So, for example, let's say on the baseball team, has a mean of 150 and standard deviation of 20, and the football team, the mean weight has mean 180 and standard deviation 25. Okay, is it more unusual that a baseball player weighs 170 or a football player weighs 200? Okay. A 170-pound baseball player or a 200-pound football player? Okay, the answer is simple. All we have to do is calculate the z-scores of whatever it is that we're looking at, and the larger z-score, or the more extreme z-score, is the one that's more unusual. So for baseball, the z-score is going to be 170 minus 150 divided by 20. The mean is 150, the standard deviation is 20, so we get 20 over 20. We get a z-score of 1. For football, the person is 200 pounds, the mean is 180, and each standard deviation is 25, so we have 20 over 25. We get a z-score of 0.8. So in this case, 1.0 is larger than 0.8, so this z-score is more extreme. And therefore it is more unusual. And that's it. That's all z-scores are. Okay, so please make sure you understand that concept. There will be a couple questions on, or at least a question on it on the quiz.